There are quite a bit more notes for 6.1. So what I want you to do, 6.1 is on similar polygons. What we're going to do is we're going to do a couple things. Let's go ahead and have you write down this stuff right there. Now is a good time to press enter to let the students write this down. When they're all done writing, go ahead and press enter again to press play. And coming back to you, students have that written down. So the only other things that I want is from scale factor down to twisted triangles, and then everything else will be examples. So from scale factor to twisted triangles, let me zoom in on that just a little bit, right about there. Go ahead and pause the video right here by pressing the enter button now. Coming back to you. The whole reason we learned proportions in 6.0 and did those problems is because there's a direct correlation to how this works for triangles. There is a symbol for the word similar. Similar has this little symbol. It's just a single wave by itself. It's kind of the thing that's on top of a congruent sign. Similar polygons are proportional, which is why we started off with proportions in 6.0. And what we're going to end up doing is creating these extended ratios. And if we're talking about triangles, and there's three sides, and we're talking about similar triangles, there might be like the first side compared to the first side, and the second side compared to the second side, and the third side compared to the third side. There might be proportions that have three things equal to each other. Don't freak out about that. There might, if it's a four-sided shape, there might be four fractions that are equal to each other. And so when we're dealing with these, they can be written as fractions or with a colon in front or with the word two, but I prefer that fraction just because it'll help you remember to put things in lowest terms. So how do you know if something is similar? How do you know if things are this wavy line? They are similar if the corresponding angles are congruent. If all the angles match, then the two objects are similar. This is where I want you to think about those triangles. Let's just start off with the equilateral triangle. Remember how we talked about, angle, 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 how that wasn't a thing because we could have different size triangles. They're not congruent to each other. They're not congruent. But let's say this is 3 and 3 and 3, and this is 6 and... Oh, no. Let's use 7. It's 7. 7's a lot better. Let's say this is 3, 3, and 3, and all the angles were 60, and these were all 7s, and because it's equilateral, they're not congruent, but they are similar because their angles are all congruent to each other. Two polygons are similar and or if the lengths of the corresponding sides are proportional. This is 3 to 7 and 3 to 7 and 3 to 7. They're all the same proportion. They're all the same ratio. That's what that means. That if they are, then they're similar. So we're going to figure those things out in these problems. The converse of this is also true. What does that mean? That means that if the corresponding sides are proportional, if 3 to 7 is the same as 3 to 7 is the same as 3 to 7, then it's similar. If all the angles match up, then it's similar. We just go and use this part first and that part second, and it is also true. Lastly, we're going to talk about this thing called scale factor. It's not my last thing, but I guess it's the second to last. The scale factor is the simplified ratio of the corresponding sides of similar polygons. In this example, the scale factor is 3 to 7. 3 compares to 7 as 3 compares to 7 is 3 compares to 7. It doesn't get in lowest terms from there. But that's what a scale factor is. It basically says what the ratio is in lowest terms. And we can use it to figure out what any missing pieces are by setting up proportions. I'm going to show you some examples of that in a second. The last two things that I had you write down were the tricky questions. The hardest part of this section is overlapping triangles. I had an example there. This was number 14. These are overlapping triangles, this triangle and this triangle. When you're dealing with overlapping triangles, what's important about these ones is to realize if you're using the left side of the small triangle and you're comparing that to the big side of the left triangle, the big side of the left triangle might be not just 8. The big side might be 20 plus the 8. With that being said, you might be fooled into thinking that overlapping triangles, that you use the 20 and the 8, it should be 20 and 28 when you're dealing with these problems. So keep that in mind. The other thing is twisted triangles. Here's an example of a twisted triangle. Sometimes you look at these triangles and you think this might be the same as that and this might be the same as that, but what actually happens is sometimes they twist the triangles like, hey, these ones are going to be the same, but I'm going to do this. And they might twist one and make this one match this side and this side match this side. And here's how you can tell. You need to sometimes pay attention to the letters M and P, M, then N, then P. That matches up with Q, then R, then P. So if you notice that these are going in opposite directions, then that means it's twisted and the top doesn't match the top. That top matches this one and this bottom matches that one. So keep that in mind. That's why I had 14 and 15 off to the side to explain those two tricky questions for you. So that brings us to my first example. I'm hoping you have the worksheet in front of you. So since you have that worksheet in front of you, let's look at number 6, and you could do this on your worksheet if you would like. Determine whether the polygons are similar. Give the scale factor of the left polygon to the right polygon. So we're going to have to say this one compares to this one. We have to complete the statement of similarity, and if it's not similar, we write not similar for both A and B and explain. Okie dokie, I see a 49 degrees, I see a 49 degrees. Mr. Lee would love that. He is a huge 49er fan. Anytime he sees a problem with 49, he gets super excited. Me, I don't care. I like football. That's it. Anyhow, I see an 88 and I see a 43. I see these numbers and nothing really matches yet, so I'm not sure if it's similar or not. But one thing I do know is if all the angles match, then I know that it will be similar. So here's what I'm going to do. I'm going to add these two numbers up together. 49 plus 88. I get 137. And what I'm going to do is I'm going to subtract that from 180. To figure out what this angle has to be, and that angle has to be 43 degrees. And I can see something there. There's the 43, there's the 43. These two angles match. I bet you anything, if I added these up, and I bet you that angle has to be 88. Let me double check that with the calculator. 43 plus 49 is 92. 180 minus 92 makes this 88 degrees. Angle matches this angle. This angle matches this angle. This angle matches this angle. And what we wrote down before, if the corresponding angles are congruent, are all the angles congruent, then the two polygons are similar. So guess what? They're similar. Yay! B, C, D. Let's go to part B first. B, then C, then D. 88 degrees. Which one's 88 degrees over here from the left polygon? We got to use triangle. H matches with the B. C is the second letter. It's 43 degrees. I got to find the second letter that needs to match up with C. It is I. And so that must mean D is the 49 degrees, and the 49ers are last. What do you know, Mr. Lee? I'm sorry. Anyhow, the last thing that says, because we knew that it was similar, what's the scale factor? Well, how do you figure that out? Well, now that we have this similarity statement, I use it a lot. I'll look and I'll say, okay, well, let's pick the smallest one, 6. And that is DB, the first and the last. So HJ, the smallest one, should be 4. And I picked the smallest side and the smallest side because then I have the smallest numbers to deal with. The scale factor, it tells me to use the left one first and then the right one second, the left one, then the right one. And if you're wondering why I'm doing that, is because that's what matches between the 49 and the 88, between the 49 and 88, that's what matches, 6/4. I have to put this in lowest terms. And so this is a great time to remind you that your calculators can put things in lowest terms. If you ever are wondering how to do it, use that fraction button and press equals. It will put these in lowest terms for you. If you're not sure if it reduces, like if I were to put 3/2 and I press equals, that's the lowest it gets. It will not change it at all. But if you had the other one, 6/4 is 3/2, that is your scale factor. And you could write this as 3/2. You can write it as 3/2, or you can write it as 3/2. And like I said, I prefer the fraction, so just write it as a fraction. Number 8. In the diagram below, find each of the following. It tells me right off the bat that this triangle PRQ is similar, that's that symbol, to triangle DEF. So these are already similar. It is given to you. We don't have to figure out if it is or if it isn't. But we're going to use the fact that triangle PRQ is similar to DEF. We're going to figure out what the scale factor is. We're going to figure out what angle D is, what angle R is, what angle P is, what DE is, and what FE is. So let's figure that out. Let's see. Let's start off with this. Q is 89. Since Q is the third letter over here is F. I know that F has to be 89 degrees. That's the first thing that jumps out at me. The second thing that jumps out at me, that didn't answer any questions, by the way. The second thing is that this angle E is 35 degrees, and E is the second letter, so the second letter must be the same angle as that, which is R. R has to be 35 degrees. And now I have 2. That's actually one of the questions. That's this one right here, 35 degrees. Now I have 2 of my 3 angles. I bet you I could subtract those from 180. 180 minus the 35 minus the 89. And I know what's remaining here has to be 56 degrees for both of these triangles. And that answers that question. D is 56 and P is 56 degrees. And so now, one thing I need to point out to you, when things are similar, the angles are congruent, but not the sides. The sides are in proportion. Angles are the same, but the sides are going to be in the same ratio. What does that mean? That means that we're going to have to set up proportions to figure things out. I see that this side DF is going to be the same as PQ. I can use the similarity statement. The first and the last is PQ compares to DF. So let's do that. PQ compares to DF. PQ, DF. I can use this to figure out all the other sides. This, because I know it's similar, are going to be our, if I put it in lowest terms, it'll be our scale factor. Let me figure out what that scale factor is. 20 over 24 in lowest terms is 5 over 6. This scale factor means that this is 5/6 of the size of that one. And if I know that, then what I can do is I could set everything else up to figure that out. If I want to know, let's make sure, let's see. The 20 comes from this triangle. So I want to use the 40 from this triangle. 40 is going to compare RP. RP is going to compare to DE. It's going to compare to DE. This is where we have these extended ratios. This is where knowing how to solve what we did before, where we did the whole 6 times 40 and 5 times this missing DE, you could even say, like, this is your x. We were trying to figure out what that is. 6 times 40 is 240. You could divide by 5, and what we can do is we can figure out 240 divided by 5 is 48. This other side has to be 48. DE has to be 48. Oh, and that's not a degree. Let me erase the degree symbol. It's a length. We know that it goes in the proportion of 5 to 6, and we did 40 compared to the 48. That also means that the 36 is going to compare to this FE. And so I can just go off to the side and I can say 5 over 6 from 5 over 6 is going to compare to 36 over FE, whatever FE is. And you'll do this so much that you're going to get really used to doing 6 times 36 is equal to 5 times this missing FE. And that's what we want to figure out. How long is it? So we'll divide by 5. And so sometimes you're just going to just get used to 6 times 36 divided by 5. 6 times 36 divided by 5. This one comes out as a fraction. You can write it as a fraction or a decimal. It doesn't matter. I think as a decimal it's 43.2. And as a fraction it's 216 over 5. Looking to see if I set that one up correctly. I believe I did. Don't freak out if you get a decimal on one of them. It's not a big deal. Moving on. Number 10. So in the same way, if they tell you a statement that has this is called a similarity statement. If they tell you that they're similar, then that means they're in proportion. You just have to set them up. And if you don't know how to set them up, use the letters. This JK is 3. That's going to compare to QR. That's 9. JK compares to QR. And if I want to use this, JL is Z, first and last. QS is Z plus 4. We can figure out what Z is. And we can figure out what the scale factor is. This will help me figure out the scale factor. The scale factor of JKL to QRS. I can just do this for the scale factor. I can reduce this as 1/3. That's really simple. I can answer that question before I even figure this other one out. And then this goes back to what we did before, where we just multiply 9 times Z, and 3 has to multiply the group of Z plus 4. This is in a group. Don't forget it multiplies to both. Most common mistake is students forget to multiply it to both. Subtract your 3Z. You get 6Z is equal to 12. And you divide by 6, and you get that Z has to be equal to 2. Which brings me to the end of those examples. The only other thing I wanted to do is I didn't want to do these problems for you. I actually wanted you to look at them. But because I made mention to the tricky questions that were right here, I might as well talk about them real quick. when you're trying to solve and figure out A, B, C is similar to A, D, E, if you're doing number 14 and I have small left, small right, big left, big right, what that really means is when you're looking at number 14, if I'm using this triangle, the small triangle, the left side and the right side of the small triangle, and you have 20 over 15, that will be equal to think of it as left side over right side, big triangle, the big left side is not 8, it's 28. That is such this thing right here, I can't tell you how many students mess it up. Big left, big right is 2x plus 3. That's the thing. The kids who miss this question, they just try to use the 8, the 20 and the 8. But remember, if I have the right side as part of the big triangle, I have to have the left side that is part of the big triangle. You will solve it just like that. So I'm not going to solve it for you. I just want to talk about how to set it up. And then same with number 15. If you look at this, MNP, sometimes I'm going to recommend MN double P triple, just in that order. Q single, R double, P triple. And that way you can line things up. The 2 and the 3 is x plus 8. The 2 and the 3 is the 3x plus 9. This compares to this. The x plus 8 compares to the 3x minus 9. That's important because if you don't line up that x plus 8 is part of this triangle, then you're not going to get anything else to line up where it's supposed to be. You can figure out the scale factor if you want to, or now you could cross multiply, but don't forget it's a group. 28 times the x plus 8, and then the 24 multiplies the 3x minus 9. I'm not going to solve it for you, but I definitely wanted to start it for you so you knew how to set it up in case you were trying. That's the end of these notes. You are going to have a lot of time to work on these, and I definitely would recommend that you work with a partner as you're working through these things.